Hello, juniors. Today we're going to continue with exponents. Today we're going to be solving exponential equations. So the objectives for today's class are two. Number one, solve exponential equations. And number two, interpret and apply properties and laws of exponents, which, as you can see, I have put all the laws of exponents that you need to know. This is part of electronic assignment number 35, which I already posted on Google Classroom. So basically, these are the laws that you need to know in order to be able to solve exponential equations. Remember, these laws are not in the formula booklet, so you need to learn them, okay? So not in the IB formula booklet. Okay. So let's see how to solve exponential equations. Actually, solving exponential equations is kind of easy. There's only one main rule, which is that to be able to solve an exponential equation, the condition is that the bases must be the same. Okay, so that's like our main goal to achieve before actually solving the exponential equation. So if you take a look at the first exercise, it says solve 3 to the power of x minus 1 is equal to 3 to the power of 5x. As I told you, the objective is first of all to seek for having the same basis. Okay, in this case, we already have the same basis. This is a very basic example. So once we have the same basis on both sides, then we can equate both exponents, right? So we can just say here that, well, first of all, the condition, which is having same base. Okay, if that is achieved, then we can equate the exponents and say that x minus 1 must be equal to 5x. And then we just solve for x, which is something easy, right? Negative 1 equals 4x. So x, or negative 1/4, is equal to x, okay? And that's how we solve this exponential equation, okay? That was an easy example. Let's go to the second one. In this case, you see that we don't have the same base, right? So I need to do some transformations in order to acquire same bases, right? One thing that I see is that 81, for example, 81 is the same as saying 3 to the 4th power, right? So I can rewrite this expression by saying 3 to the power of 3x plus 1 must be equal to 3 to the power of 4. And now I'm back to the same situation we had in the first problem. We have the same basis, so we can equate the exponents. So 3x plus 1 is equal to 4. And then we solve for x. 3x is equal to 3, so x is equal to 1. And that's the results. Okay, let's go to the next one. This looks a little bit more difficult. Let's see. It says 3 times x to the power of negative 3/5 equals 24. In this case, pay attention that the exponent is only affecting the x, okay? If we do not have a parenthesis involving all of the numbers, or 3x in this case, then the exponent is only affecting the term we have to the right, okay? So since the exponent is not affecting the 3, the first thing we can do is take the 3 dividing to the other side, right? So we can say that x to the power of negative 3/5 is equal to 24/3. And 24/3, as you know, is equal to 8, right? So x to the power of negative 3/5 is equal to 8. Now I need to solve this. How can I solve this without using a calculator? Remember, the objective is to solve for x, right? That means leave the x alone. If I want to leave the x alone, I'm thinking about doing the following. Leaving the x alone means having only x, right? And only x is always to the power of 1, right? It's the same as saying x to the power of 1. So I will look for making some kind of transformation here in order to obtain the exponent 1. And one thing I can do to obtain that is, for example, multiply, let me do this here, 3 to the power of negative 3 over 5, and all of this to the power of, in order to acquire 1, I need to multiply this to the power of negative 5/3, right? Which is the negative, or sorry, the reciprocal of this number. You see that if I multiply this times this and this times this, I'm gonna get 15 over 15, which is which simplifies to 1, right? So if I do that to one side, I need to do it to the other side. So this is 8 to the power of negative 5 over 3 as well. Okay, so because I did that, you'll see that on this side, let me do this with orange, the 5 simplifies with 5. I'm going to use a little bit thinner. 5 with 5 and 3 with 3, and the negative goes with the negative, right? I am applying, just for you to realize, I'm applying this law over here. Let me see. Where is it? It's to the power. Here, this one, the last one. A to the power of n to the power of m is equal to a to the power of n times m. That's the one I am applying here. I'm multiplying these two exponents and they simplify and we get x to the power of 1. That means that x to the power of 1 is equal to 8 to the power of negative 5 over 3, right? But this is not in its simplest version yet. If this is to the power of negative 5/3, I can rewrite this by applying this law. I can take the 8 to the down to the denominator in order to have a positive exponent, right? So I can say that x is equal to 1 over 8 to the power of 5/3. Okay? But I also know that 8 is the same as saying 2 cubed. So there's something I can still do here in order to simplify this a little bit more. I can say that x is equal to 1 over, instead of writing 8, I'm going to write 2 cubed, and all of this is being to the power of 5/3. Let me see if I can put this a little bit better. 5/3. Okay, so you see that here the power of 3 inside simplifies with this one over here. So we only get, as a result, 1 over 2 to the 5th power, okay? And 1 over 2 to the 5th power, 2 to the 5th power is 32, right? So, this would be equal to 1 over 32. And this is the simplest form, so this would be our final answer, okay? So you see that I applied 2 to 3 laws of exponents here in order to be able to solve this equation. Okay, let's see the next one. Number 4. It says solve 25 to the power of 4x minus 3 equals 1 over 125 to the power of x plus 1. Okay, the first thing I always try to do is try to have the same basis, right? If I have 25 and 125, I immediately would think about having the same base, which is base 5, right? Because I know that 25 is 5 squared and 125 is 5 cubed. So that's the first thing I'm going to do. I'm going to change the bases. And in the first case, it's 5 squared. And this is, again, to the power of 4x minus 3. And this is equal to 1 over 5 cubed. And all of this is to the power of x plus 1. Okay, now I need to do some transformations in order to have both bases in the numerator, right? In order to be able to equate the exponents, right? So one thing I could do here is I have an exponent to the power of another exponent. So I can multiply this two, and we will have 5 to the power of 8x minus 6, right? And on the other side, I can take this up to the numerator by changing the sign of the exponent. I'm going to do that because I need to have both bases in the numerator in order to be able to solve this. So 5 to the power of negative 3, and again to the power of x plus 1. Okay, so I'm going to do the same thing I just did here. I'm going to multiply the exponent on the right side, right? So this stays the same. And this would be 5 to the power of negative 3x minus 3. And there you go. Now we have same basis, and both of them are in the numerator, so I can equate the exponents and say that this is 8x minus 6, and this must be equal to negative 3x minus 3. And then I need to solve this. I can take the 3x to the other side. This would be 11x equals negative 3 plus 6, that's 3. So x is equal to 3 over 11. And this is the result. Okay. I think we have one last exercise. Yes. Okay. So let's go to number 5, which says solve 5 to the power of x times 7 to the power of x equals 35 to the power of 2x plus 1. Okay, for this case, I see that I have different bases here, right? But we have the same exponent. If you take a look at the laws of exponents I posted in the beginning, you see that we have this law over here, a to the power of n times b to the power of n. That means different bases. And what can we do if they both have the same exponent? I can multiply both numbers and take them to the same exponent, right? So I'm going to write that here. This is the same as saying a to the power of x times b to the power of x is equal to a times b to the power of x. And that's exactly what I'm going to do in order to be able to solve this. So here I can say that this is these two terms. If we multiply them, we're going to get 35 to the power of x. And this is equal to 35 to the power of 2x plus 1. And then this is easy, right? Because we have the same base, so we can equate the exponents. So we're going to say that x is equal to 2x plus 1, and then we're going to solve for x. We're going to get that negative 1 is equal to x. I'll write that here. Negative 1 is equal to x. And that will be the result. Okay, so I hope this was clear. You're going to be practicing with more exercises about this later on, but I think this is quite easy. If you dominate the laws of exponents, then these problems shouldn't represent much of a challenge for you guys. Okay, so that's it. If you have any doubts, please let me know. See you.